Let us consider this question based on the bend and block break. So we are given that the bend and block break shown in the figure has a drum diameter of what? 800 millimeters. So the drum diameter is given. That is, according to this, the diameter is, all right, let's convert to meters, divide by 1000. So that's 0.8 meters. And thus we can have the radius divide by 2, that's 0.4 meters. So they're saying here there are 12 evenly spaced blocks. So the blocks that we're given, they are 12 of them, the number of blocks. Number of what? Blocks, the wooden blocks that will be given. And also each subtending an angle of 10 degrees at the drum center. Each subtending an angle of what? Of 10 degrees at the drum center. Each. So the angle that we are given there is 2 theta. The included angle, this one, from what we had. Remember our introduction. There is theta, the half angle. There is 2 theta, which is being taken as what? As the angle that is affecting each of the given sections. Let's say we are to consider the blocks combined with those spaces that you're given. It is what? 2 theta, the included angle. So here, do not worry to say, all right, what about the space, this and that? Already they gave us the angle there. So even they were gonna be having space, having same angle. It was gonna be 10 like that, 10, 10, 10 throughout. 10, 10 throughout. So already, guys, we have got 2 theta, which is equal to 10 degrees. So therefore, the half angle theta now from this one, our half angle theta is gonna be 10 over 2, which is what? 5 degrees, which is the half angle. So there is the included angle and the half angle. So the angle that is here, the angle, each subtending an angle of, once they give you like this, you take this one as your 2 theta. So that is where I was actually referring before to say it also depends now with the author. Some other textbooks, they will be referring that as the half angle. They'll be referring as the half angle, which we want to avoid in terms of the exam answering, guys. That is what? 2 theta. Also, according to our introduction, that is what? Your 2 theta. So meaning to say you obtain the half angle from there. So if you are using, let me just show you this one. I think, oh, sorry, I'm not supposed to show this. Sorry, guys. Let's hope they're gonna not affect my video because of that. All right, here, if you check, I had something from this one. It is TVET series. Yeah. If you check this example that they did here, they said, I want you to just see something. The issue of the author now that you'll be having for your textbook. They were saying we have got 14 break, whatever that we have, which is okay. 14 break blocks that are evenly spaced, all right? Then each block has a subtending angle of what? Of 12 degrees at the break drum center. Exactly the same thing that we are given here, exactly the same thing that we are given here to say there are 12 evenly what? Subtending an angle of, nothing changed, only that the values, all right? But I want you to see now how do they answer now? How do the author now of this textbook attempted it? Now, when they are using that here, because they said it is 12, okay, this one, which we are saying is 2 theta. But here, if we check down, all right, let's go. So if we check here, where the half angle is used, because this theta here represents the half angle. They are using that as what? As 12. Look, they are using that as 12 instead of 12 divided by 2, which is what? Which is 6 degrees. According to the way that we had on our introduction to say each here will be referred as 2 theta, so we must divide by 2. Exactly what we have on our question here, where we had 10 and we had to divide by 2. So you look into that, they never divided that one by 2. So this is now the taking of the author now to say the author is taking that as the half angle, is taking this 12 as what? As the half angle. So for exam purpose, if that is given, divide it by 2, all right? For exam purpose, guys, let's just be on the safer side, divide by 2, all right? So that is it for this one. We are now having the half angle. So let's consider the coefficient of friction between the blocks and the drum is what? 0.35. So there is the coefficient of what? Of friction, 0.35. So I think for this one, I've answered you guys so that we do not have questions. Say, are you dividing by 2? You might be using that one for the TVET series. Then you see, they never divided by 2. So for safety, divide that one by what? By 2. Okay. So the brake must be able to absorb, remember the power, like I said before, power that is absorbed by what? The brake. So the brake absorbs 100 kilowatts of power at a speed of what? At a speed of 180 revs per minute. Then the distances are given from A to B, which is what? 300 millimeters. Then from B to C, which is what? 600 millimeters. So that is what you're given so far. So far, that is what we have. And the question here was calculate. All right. Calculate one, the band tensions. The band tensions. So we cannot consider the diagram here to say we can use the moments. In this case, we are limited. We do not have this force that is applied to the lever. They are actually asking it later on. So application of moments is something else. We cannot think about that for now. So you're going to leave this diagram for now. Let's consider what we have. How can we determine the band tensions, which we are going to have for this one and for this one? We do not know which one is T1, which is T2 because of what? The rotation. We must know the rotation first. So that is, we are going to consider this one separately, band tensions. Let's see what we have here. So they are T1 and what? T2. One, we talked about the band tension ratio as something that is now different from what we had before. Remember, I said of all the calculations, they are going to remain the same. But the band tension ratios, using this, it is going to help us to find T1 in terms of T2. As we have got everything, the half angle, everything we have. So we are going to have that one and have it T1 in terms of T2. It's going to depend with what, how you want to have your answers, all right? So we saw that from tension ratio. So from band tension ratio. T1 over T2 is equal to what? So we have 1 plus the coefficient of friction times what? The tan of theta. All right. Here we also have the same, just a negative. Then you raise this to the exponent of what? N, the number of blocks. All right. So let's do this and substitute everything. We have got the coefficient of friction. Our half angle is there. So thus T1 over T2 is going to be equal to what? Substitute 0.35, the coefficient of friction, times the tan of the half angle theta, being the half angle, which is what? 5 degrees. So that's the tan of what? 5 degrees there. You must be very careful. All right. 1 minus 0.35 times the tan of what? 5 degrees again, raised to the exponent of n. The number of blocks that we are given is what? Is 12. So that's to the exponent of what? Of 12. All right. So I want you to simplify this properly. All right. You simplify, just round off to 3 decimal places. All right. Or you can just round off to any decimal place that you're comfortable with. So that is going to give us, if we simplify this part, all right, it was gonna give us, oh, sorry for this, I don't know what happened here, 2,086. So this is what we have. So this represents the band tension ratio. This one, T1 over T2 is equal to this. It is the band tension ratio that we have just calculated. But we are not asked to calculate that. What we need here, we can have a relationship between T1 and T2, a relationship. So how can we have that? Simply cross multiply. So since T1 is already on its own, so 1 times T1, thus T1 is equal to 2,086 times these two multiply each other. So that's 2,086 times what? T2. So we have formed an equation here. We have formed an equation which can help us to solve for T1 and T2. So let's just leave it as it is, since we have got two unknown values. So now the question is, do we have any other equation that can be formulated? And that equation must consist of what? T1 and T2. From what we have. From what we have so far, we are limited. Unless if we can have, or if we can calculate the value of torque. Because we do understand that it has T1 and T2. Remember on our calculations here, where we ended up from the torque formula, we ended up having T1 minus T2, which is equal to what? The torque over the radius of the drum. So if we have that torque, we can use that. It's an equation which can give us T1 and T2. It's an equation which can give us what? T1 and T2. As we have T1 minus T2 as the torque over what? Over the radius of the pulley. So therefore, let us substitute. All right, sorry, we do not have the torque so far, but we can have it here because we were given the power and what? The speed. So from that, torque can be what? Calculated from power and speed. Remember also, I referred between this. So we can have our torque here from power So calculate the torque from what? From power. So remember that's 60p over 2 pi n. Since our speed is given in what? Revs per minute. The power, 100 kilowatts. So this is 100 times 10 to the exponent of 3 over 2 pi times the speed in what? Revs per minute, which is 180. So that was going to give us the value of the torque, which is 5,305,165. All right. So just confirm with your calculations, guys, and see, because you might just make a slight mistake. So also verify with your calculators there. So this is the torque that we have, which is going to help us to find or actually to formulate an equation again for these two, T1 and T2. As we now have these two, therefore T1 minus T2 is equal to what? The torque is there, 5,305,165. Everything over the radius of the what? The drum in meters. So our radius was what? 0.4 in what? In meters. That's it. So this gives us another equation. So from this one, just gonna round off to 3 decimal places, guys. But if you want, you can maintain any decimals that you want. But as for me, all these, I'm just gonna maintain 3 decimal places. So it was going to give us actually 13,262,913. It was gonna be 9,125 like that. So this will change into a 3 so that we have what? 3 decimal places. So we formed an equation just like what we had here. So we can even substitute, because we have got T1 written in terms of what? T2. We can even substitute this in place of what? T1. It is in your hands, because it's another equation. Or since we have T1 in terms of what? T2. Do the same here. Form an equation where T1 is in terms of what? T2. So that you can simply equate the two equations in terms of what? What you're given there. Let us make T1 the subject. So T1 is equal to what? We have to take T2 to the other side. It's going to be a positive there. So that's 13,262,913 plus what? T2. So this is my equation at the end that I'm going to work with. T1 in terms of what? In terms of T2. But I have another equation that I created before, equation 1, where T1 was also written in terms of what? T2. So from your mathematics, guys, you see that it will be easier because these two, T1, T1, represents the same thing. So what it means, what we have on the right-hand side must be equal. So we just have to equate the two. Therefore, 2, 086 T2 must be equal to this one that we have representing the same T1 as before. So that's it. We are done as we have got this equation. It is easier now for us to solve for what? For T2. So that's it. Take T2 to the other side. It's going to be a negative. So that's 2,086 minus 1, which will give us what? 1,086. But remember, it is what? T2. And that's equal to this on the right-hand side. So to find T2, simply divide as we have got a product. All right, so that's it. We are done. So this is it. Our T2 is equal to what? Divide here. And also rounding off to 3 decimal places. That was going to be 12,212,627 Newton. So remember, this is the tension that we have on the slack side, of which you can even convert to kilonewton, guys, as we have got this too big. But it's fine. You can even use it as it is. To kilonewton, divide by what? Divide by 1,000, what you have. All right. It is going to be in what? Kilonewton. So it's going to be 12,221. This is going to change into a 3. All right. So that's kilonewton. So this is your T2. And with those two equations that you had, because you had those equations, T1 in terms of what? T2. So you can choose any one of these equations to find what? T1. You can choose the first one, substitute there. You can choose the second one. It is in your hands. In your hands. But if you are to use the second one, make sure that you have T2 not converted, but as a decimal like this one, the way that we have written this, not with those kilowatt watt. But if you are using the first one, there's no need. You can just have it under those kilovolts. This one is just direct multiplication. So using equation 1, T1 is equal to what? From equation 1, T1 is equal to 2,086 of what? Of T2. So therefore, T1 is equal to 2,086 times T2. So it is either you're going to use this one in Newton or you're going to have the one in kilo Newton. So I'm just going to use the kilo Newton, 12,213 kilonewton. So meaning to say whatever that I'm going to multiply here will remain in what? In kilo Newton. And to 3 decimal places, that was going to give us 25,476 kilonewton. So this is what you're going to have. You have the tensions T1 and T2. Just like that. This is what you want. This is what you need. Just like that. T1 and T2. So we must be very careful, guys. You see where we had to work it from. The bend tensions from our bend tension ratio from the torque. Sometimes it will be calculated directly from our moments. If let's say we are given the force and they also gave you the direction. But in our case, to use the diagram, we're limited. So that is the only way that we can have. Unless you have another way that you just figured out giving the same answers, all right? We can actually jewel on that, work on that for the next questions that we are going to have. All right, so anyways, let's continue and see how to attempt the other questions here. So this is it. It was a lot, but as we can see, yeah, that is it. You just have to be very careful when attempting. Follow all the steps and also try to apply the formulas. Use all the formulas that you are having from the information that you are given. All right, moving on to question number 2. They want us now to calculate the force required on the lever if the drum rotates clockwise. the force applied, force required on the lever. All right, we have T1 and T2, remember? 25,476 kilonewton. And also, we calculated our T2. It was 12,213 kilonewton. So you find out that these tensions are for the bends that we do not know exactly where is T1 and T2. Now that we have the rotation of the drum, the rotation of the drum is there. So we can tell to say which one is T1, which one is T2. Clockwise. How the clock moves, clockwise. So meaning to say we are moving from T1 going to T2. So T1 is the one that we are going to have on the what? On the right side. So T1 is the one that is passing through the fulcrum at B. So this is the bend. The tension there is what? T1. And for this bend, it's going to be our T2. This one from A to the what? To the drum. So that's our T2. The rotation of what? Of the drum. Then apply your moments, just like that. So this is what you now have. According to this, it simply means, all right, it simply means here we have got a sketch, all right, from A to B, all right. So this is A giving us what? T2. Then this is B, which is our fulcrum, this one. Remember, this is A. Then this is horizontally given to what? To C, where we have got that force that is applied here. So we must find this F. So as I said, we now know that this is T1 and T1 passes through the what? The fulcrum. So T1 is here at what? At B. So meaning to say, guys, as of T1, there is no any effect that is going to happen here because it is at the fulcrum. So there is no movement. There's no distance to the fulcrum. Say T1 times a certain distance. So it will be actually out of our equation. All right, so let us apply our moments because as we can see here, we are having, this is how you apply the moments actually. Just take it this way. This is, I'm just going to maintain these millimeters. If you want, divide by what? Divide by 1000 to convert to meters. It is up to you. All right, or just use millimeters. So taking moments, like I said before, you take your moments about the fulcrum. So taking moments about the fulcrum. We are going to consider the clockwise and the anti-clockwise moments, where the clockwise is going to be F going to the fixed point that is in a clockwise direction. So F is going in the clockwise. Then T2, T1 cannot be considered, guys, because this here is on the what? On the reference point where we are taking our moments from about. So meaning to say here, there is nothing that is going to happen on what? On T1, there's nothing that we're going to get. So you consider T2. Which direction is it going to move back to the fulcrum? It's going this way, anti-clockwise. So T2 is the one for the what? Anti-clockwise. So that's it. Those are the only two to be considered. So you now use the formula F times the distance back to the fulcrum. The moments now. So moment, force times distance. So F times 600. You can use 0.6 if you have converted. Must be equal to, in the anti-clockwise, there's only T2. So that's T2 times the distance now. So look what happens here. You take the distance that is slanting this one. T2 is found this way. It is slanted like this. You use the slanted distance, all right? So this one you take as it is, guys. Do not worry. So it is what? T2 versus this slanted distance, which is what? 300. As T2 is given as the slanted distance, I mean, as it is given slanted, you use the one that is slanted like that. So that is the way to answer this question. So remember, we have the value of what? Of T2. We calculated it. We have it. So you're going to substitute that T2. You can even use in kilonewton as it is, all right? So I'm just going to use in kilonewton as it is. So F times 600 is equal to T2. That's 12,213 kilonewton. So this is in kilonewton, guys, or you are simply going to use times 10 to the exponent of 3, whatever that you want. All right, no problem. Times this 300. So whatever that you are going to have here, divide by what? 600. Divide by 600. So our F was going to be a lot of. All right, so whatever value that you're going to have, 610, whatever, divide by 1000, convert to kilo. So it was going to be 6,107 kilo Newton. So whatever value that you're going to have on your calculator, divide it by what? By 1000. So this will be the force that is applied to the what? Or on the lever. When we are considering that the drum is rotating in a clockwise rotation. The drum is rotating in a clockwise rotation. That is what we are given here. So the second part, you see that now they want us to consider the same force required on the lever. But this time, if the drum rotates anti-clockwise. So when it is anti-clockwise, this is going to change, guys. The movement has changed. So meaning to say our T1 and T2, the way that we used before is going to also change. It is going to change. Because now the drum is going in the anti-clockwise. So anti-clockwise, what is the effect? We are moving in this direction, anti-clockwise, the opposite of the clock. So thus, in our movement, we are moving from T1 to T2. So T1 is the one on the left side. This time, T1 is here, and T2 as a bend tension here is going to be what? On the right side. So the direction is very, very important. So this time, this is where our T1 is. This is where our T2 is, as T2 is passing through the what? The fulcrum at B. So meaning to say, just like what we had in our previous question, we're not going to consider T2. We are going to only consider T1. What we had, clockwise moments, anti-clockwise, still the same. F clockwise, T1 is the one in the what? Anti-clockwise. So the clockwise, that's F times the distance, 600, must be equal to, here, T1 times slanted distance again. It must correspond just like that. So we have the value of T1. We have it. We calculated this one before. So substitute back We are done. So that is how we can play around with these typical questions. So this is what? This is gonna be F times 600 is equal to T1. So T1, that was 25,476 kilo Newton, kilo times 10 to the exponent of 3 times 300. So simply divide by what? By 600. Just like before, guys, you see multiplying by 10 to the exponent of 3 was just a waste of time because you are going to divide again by it. So whatever, guys, that you're going to have here, divide by what? By 1000 so that you convert your answer to kilonewton. So it was going to be 12,738 kilonewton. So this is the force that you're going to have this time as we consider any anti-clockwise rotation of the drum. So exam, they can ask based on one rotation, is it clockwise? Is it anti-clockwise? So here it's just a preparation, so we can consider both. All right, but as for exam, it can just the question can just focus on one rotation only. Is it anti-clockwise? Is it clockwise? So revise based on this as many questions as you can. So we are just going to notice the only difference will be the connection. Now, sometimes you find out T2 is at a certain distance away from the fulcrum. It's no longer connected direct. So when you say on those moments, you must consider also T2 as part of what? Calculations. That is the only difference that you can maybe get yet. Otherwise, the rest, guys, is just one and the same. It's a repetition. It's a repetition throughout. So let's do revise.